In this video, I'm going to solve the second order PDE, which is equals to x squared y subject to the conditions u at x0 is equals to x squared, u at 1, y is equals to cosine y. So we are given that second order PDE and those conditions. This PDE, I can just try to rewrite it. What it is saying there, that's the partial derivative with respect to x of the partial derivative of u with respect to y is equals to x squared y. But when we have a partial derivative with respect to x and we need the function, what we do is we can integrate both sides with respect to x. So integrate both sides of this equation with respect to x. On the left-hand side, we'll just remain with partial derivative of u with respect to y. Then on the right-hand side, we'll integrate x squared multiplied by y with respect to x. When you do that, what you get there is x cubed y divided by 3. So we have the partial derivative of u with respect to y is equal to x cubed y divided by 3. But we are integrating with respect to x when we had a partial derivative here. So our constant is just not a constant. It's a constant in terms of x, but it can be a variable of y. So we have plus f of y. Just because we're having partial derivative with respect to x, we'll be treating y as if it's a constant. So our constant there will be in terms of y. It's a function of y. Now when we are at this stage, we are having the partial derivative of u with respect to y. What we can do there is we can integrate both sides of this equation with respect to y so that we get a u. So what we would get there is our u is equals to the integral of x cubed y divided by 3 with respect to y plus the integral of f of y with respect to y. But when we integrate this first part here, x cubed y divided by 3 with respect to y, we are treating x as if it's a constant. So what we would have there is x cubed y squared divided by 6. Then plus the constant of integration. The constant of integration, we were taking the partial derivative with respect to y is there. So our constant of integration there will be in terms of x. It will be a function of x. So our result there is u is equals to x cubed y squared 6 plus a function g of x. And then this part here, the integral of f of y with respect to y, we just write it as it is, the integral of f of y with respect to y. So we have our u there. We now apply the conditions that we are given. We are given that u at x0 is equals to x squared. What we are doing there is in our equation for u there, where we have y, we put 0. So what we would have there is the result is 0 plus g of x plus the integral of f of 0 with respect to y is equals to x squared. But when you are looking at this, the integral with respect to y, when you are integrating with respect to y, the result that we get is a function of y. But on the right-hand side, we don't have any function which is in terms of y there. So what would then just mean that there is no y, so that part will be 0. So we have that our g of x will be equals to x squared. So we have our g of x is equals to x squared. We now look at the other condition that we are given there. U at 1, y is equals to cosine y. What we are saying there is in this equation for u there, where we have x, we put 1. So when you put 1 there, we would have y squared divided by 6 plus g of 1 plus the integral of f of y with respect to y is equals to cosine y. Now what we can do is we can put these two on the right hand side so that we have the integral of f of y with respect to y is equals to cosine y minus y squared divided by 6 minus g of 1. But we have our g of x here, and we can use that to evaluate g of 1. G of 1, we are saying where we have x, we put 1. So g of 1 will be 1 squared. So it will give us a 1. So this equation here becomes the integral of f of y with respect to y is equals to cosine y minus y squared divided by 6 minus 1. So that's the integral of f of y with respect to y. So at this stage, what you are having there is we have our g of x here, and we have our integral of f of y with respect to y. We can substitute them here, and what we would have there is our u is equals to x cubed y squared 6 plus x squared plus cosine y minus y squared divided by 6 minus 1. So that's the solution there for u given those conditions.